Let's work with solving trig equations. For example, let's find all solutions to this equation here. We'll start by adding square root of 3 to both sides, which gives us tangent of theta is equal to square root of 3. Now remember, tangent of theta is equal to sine of theta divided by cosine of theta. And remembering our unit circle, the sine of theta is the y-coordinate of the point of intersection of the terminal side of its angle and the unit circle. And the cosine of theta is the x-coordinate of the point of intersection of the terminal side of its angle and the unit circle. Which means we want to find out where this ratio is equal to the square root of 3. And looking over here in quadrant 1, if we take the ratio of y to x here, which corresponds to the angle of pi over 3, we'll get square root of 3. But also if we take the ratio of y to x down here, which corresponds to the angle of 4 pi over 3, we'll also get square root of 3. That is square root of 3 divided by 2 divided by 1/2 is equal to the square root of 3, and negative square root of 3 over 2 divided by negative 1/2 is also equal to square root of 3. Which means that the tangent of both of these angles here will equal square root of 3. But not only will the tangent of those two angles equal square root of 3, but the tangent of any of their coterminal angles will also equal square root of 3. That is, theta is equal to pi over 3, or 4 pi over 3, or any of their coterminal angles. Which, remember, we can write this, theta is equal to pi over 3 plus 2k pi, where k is an integer, or theta is equal to 4 pi over 3 plus 2k pi, where k is an integer. And remember, when these angles are exactly pi units away from each other, then we can consolidate these two statements into one, namely theta is equal to pi over 3 plus k pi, where k is an integer, which would be our answer. All right, let's look at another example. Let's find all solutions to this equation. We'll begin by adding 2 to both sides, which gives us cosecant of theta is equal to 2. But remember that cosecant of theta is equal to 1 divided by sine of theta, which means that sine of theta is equal to 1 over cosecant of theta. So if cosecant of theta is equal to 2, that means we're looking for angles theta where sine of theta is equal to 1 divided by 2. Again, thinking of our unit circle and remembering that the sine of theta is the y-coordinate of the point of intersection of its terminal side and the unit circle. So looking over here, we see that the y-coordinate of this point is 1/2, which corresponds to the angle of pi over 6. But also over here in quadrant 2, the y-coordinate of this point is 1/2, which corresponds to 5 pi divided by 6. Which means that the sine of both of those angles is equal to 1/2, but not only those two angles, but also any of their coterminal angles. That is, theta is equal to pi over 6 or 5 pi over 6 or any of their coterminal angles. Which is written as theta is equal to pi divided by 6 plus 2k pi, where k is an integer, or theta is equal to 5 pi divided by 6 plus 2k pi, where k is an integer, which is our answer. And this is how we solve trig equations. Thank you, and we'll see you next time.